Welcome back to another video on AA learning. Today we're going to stick to another math concept. It will be calculus level, just a heads up, and it's going to be integration. So in this video, I'm not really going to cover like the integration rules. I can create a separate video on that. This video is going to be simply Riemann sums, and I'll be explaining what integral is, along with some practice problems for Riemann sum. And like always, I will create a document that has some practice with Riemann sums that you guys can do. Okay, let's get into the video then. So the first question many people have is, what is an integral? So an integral is basically a way to find the area under a curve of a graph. Let me show you guys what I mean. Let's say we have this graph right here, and then we have this function like this, and let's say this point is 3 and this point right here is 1, and it lies somewhere on this graph like that, and somewhere like that. Okay, basically what integration allows us to do is find the area from that point to that point under the graph. So yeah, that's what integration basically allows us to do. Now, usually what people would do is write the integral, which is that sign by the way, and in this case be 1 to 3 over whatever function that is. Well, I'll get into that in another video, but what I want to teach you guys here is Riemann sums. So what Riemann sums focuses on is creating rectangles that would create an approximation for what that area would be, because we can't take the area just simply of this graph from here to here. We don't know how to do that without like integration rules. But if we just make rectangles, we know how the area of a rectangle is length times width. So we can just use that knowledge and apply it here. So I'll show you guys what I mean. So there's 3 Riemann sums. So there's a right Riemann sum, a left Riemann sum, and a midpoint sum. So let's start with our first one, the right Riemann sum. So let me draw a basic graph. Let me just label this right Riemann sum. Okay. So this is going to be a right Riemann sum. Let's just say we have a similar type of graph. It's an exponential growing graph, looks like. So what a right Riemann sum tells us is we have to start from the rightmost point. So we can start from right here and then build like that and that, a rectangle. And so we say we want to find the area from here to here. So we would do the same thing now. So we would do another rectangle. That's like right here. Watch, because the top becomes over the graph. And now we have right there. So it would be simply like this. It's like top portion of the graph becomes on top or over the graph. And then finally, this final point. So if we wanted to take the area from right here to right here, Riemann sums will allow us to do that. But again, it would be for right Riemann sum an over approximation. So there's a formula for right Riemann sums, and I think the formula is more complicated than it needs to be. And in my examples that I'll show later in the video, I think it's easier than actually the formula makes it. So let's see. So the formula shows the summation of n, and then I is equal to 1 of f of x I times delta x. Okay, let me explain what all these pieces are. So we know summation, that's just a constant addition of something. And then this n value right here shows the number of number of rectangles that you'll use. So in a problem, they'll tell you n is equal to 4, so or n is equal to 3. So those are how much subintervals of rectangles you'll use. Okay. This delta x here represents a formula b minus a over n. Those are used when you know what your intervals of your graph are. So say this is 0 and this is 2, this x value. So the b would be 2 and then a would be 0, and then you gotta divide by the n. I'll show that again more clearer in a problem example that I'll provide. And then the next piece would probably be this xi piece. So this xi piece is right of the I term. So the I term is 1. So right of the I term. Because it's a right Riemann sum, we have to use the right of that I term. Okay. I hope that cleared up whatever this mess of the equation I think is personally. But I'll hopefully make it more clear with the practice problems I'll provide later. Okay. Now let's go to left Riemann sum. Okay, I'm going to use the same type of graph just so we stay consistent for this part. Okay, so our left Riemann sum basically uses our left endpoints instead. And as you guys will see, it will be an under approximation as opposed to the over approximation we had with our right Riemann sum. So it would be something like this, and then you'd use your left value, create something like that, and you just have to keep creating these rectangles depending on how much intervals that the question tells you. You just have to keep creating these rectangles to find the area for Riemann sum. Yeah, we'll just say that is. We'll say this is where you're supposed to find the area for this sketch. Okay, so from this sketch, you can kind of see that we wanted to take the area from here, we'll just say right here, and you can see the rectangles don't go fully over the graph as they did in the right Riemann sum. So there's some gap, see, as you can see right here, gap right here, right here, right here. So it's clearly an under approximation. So whatever the actual integral is, it'll be this value that you get from doing the left Riemann sum would be less. So again, there's a formula for this one, which I think is also kind of confusing, but hopefully I clear it up in the examples I'll provide. So the formula is summation of n minus 1 of I is equal to 0 of f of x I times delta x. Okay, so I'll again explain what these are. So delta x we know is the same as b minus a over n, and then the b minus a are basically what the intervals would be. So this x value, whatever, let's make it 0, and this one, let's just make it like 3. So it would be 0, 3 would be the intervals. And then this would be the a value, and this would be the b value. So then you just plug that in. And then we know the n term is the number of rectangles, but this time you have to subtract it by 1 because you're just focusing on the left side. You're going to ignore one of the final rectangles. And then we know the xi value is left endpoints of the ith term, and we know in this case I is equal to 0. And yeah. Okay, now let's move on to midpoint sums. Okay, so midpoint sums, as their name kind of like sounds, is just using the Riemann sum that we know, but just using the points midpoint rather than to create the rectangles rather than left side or right side. So in this case, it would be like we have a midpoint right here, and then we go right there, and then draw the rectangle like that. And then again, you can go right there. You have to go on the midpoint and then draw a rectangle right there and then right there. And then again, for the final one I'll do here, just do this. Just basically take the point's midpoint and then just draw the rectangles. So as you guys can see, this one has a more, I would say, accurate summation, like sum, when you actually want to find the area compared to the left Riemann and right Riemann sums, because it does have like this gap here, but it also has like this over approximation here. So there's like a mix of under approximation, over approximation, which like even out almost to give you a closer approximate to the actual area under the curve. So there's again an equation for this, and again, like all the equations I gave, it's I think more complicated than it should be. So it would be summation of n is of I equals 1 of f of x I over a star over I times delta x. Okay, so basically these are the same components, but basically what this x star over I means is the midpoint. You basically have to divide two values to get that midpoint. That's basically what it's indicating. Everything else is the same as I have told you guys previously. Okay, let's get into some examples. Maybe that'll make it more clear. Okay, so our prompt is going to be approximate given f of x is equal to x squared from x is equal to 0 to x is equal to 2 and n is equal to 4 sub intervals. Okay. This is something you guys would probably see, this type of prompt. Another prompt would probably be a chart. A chart basically I'm not going to go over in this video, but if you guys want a separate video just explaining like how the chart would be for Riemann sums, I can definitely do that. But just as a quick rundown, a chart would probably just be like, they'll give you some values and you just use the left side or the right side. Because I know they like to do that sometimes in AP exams. And if you guys need that, just let me know in the comments and I'll do that. Okay, but focusing back on the problem. So let's first use left Riemann sums. Okay. So let's see what we're given. We know that it's from x is equal to 0 to x is equal to 2. So let's write that down. X is equal to 0, comma 2. And it's in brackets because it's that specific value. Those are like the distance we're talking about. And we know the subinterval is n is equal to 4. That's also important to us. So back to our summation that we equation for the left Riemann sum, we know that we need to find the delta x, and we can find that with our given values. So we know that this is the a value and this is the b value. I think because a comes first, then b is next in the alphabet, and this comes first, and that helps. So it'd be b minus a, so 2 minus 0, all divided by the n value, so 4. So that's equal to 1/2, or 0.5. So what you have to do in left Riemann sum is just use the left value. You would ignore the last right value, basically. So we know each interval. This tells us how much intervals we have to do, the delta x. So each interval is going to be, I'm going to, just for the simplicity's sake, I'm going to do decimal. It's going to be 0.5. So we have to make sure each interval for 4 of them is going to be 0.5 plus 0.5 plus 0.5 plus 0.5, if that makes sense. So we would write L of x is equal to delta x times, we'd have to multiply that, whatever we get here, f of 0, because that's our first starting value. That would be, if we drew a graph of x squared, it'd be like that. f of 0, we want to find 0, so let's say this is 2. So this would be 0 because we're starting from left. So that's why it would be, if we created a rectangle, it'd be this, like this left side. I'm just making it bigger, the rectangle, just to make it clear. Okay, so it'd be f of 0 plus, now we need to go in intervals of 0.5 because that's what our delta x tells us. F of 0.5 plus f of 1 plus f of 1.5. Notice how we didn't include f of 2. That's because it's a left Riemann sum. We know left Riemann sums are going to be under approximations, and this one only has 4 subintervals. So this is 1 subinterval, 2 subintervals, 3 subintervals, and 4 subintervals. And for left Riemann sums, again, we take the leftmost value. In this case, it was 0, and we ignore the rightmost, which was 2. So we just now plug all these values that we have here. So L of x is equal to, we know this is 0.5. So I'd done these calculations beforehand just to make it simpler for you guys. So it would be 0 plus 0.25 plus 1 plus 2.25. Now add these up and multiply them together, and then you get 0.5 times 3.5, and the final answer would be 1.75. Don't forget units squared when you're finding the area. So that would be the answer if we're using a left Riemann sum. Now let's show the same process, but let's use right Riemann sums now. Let me just create a new template. Okay. And then use right Riemann sums. You guys can pause the video and try this yourself if you want, but I can go over it again to show you guys. So what you would do for right Riemann sum, again, like write down what you know. That's what I like to do, just to make sure you have a clear understanding. So we know the f of x function right here. So f of x, it's just the same problem as before, is equal to x squared. And we know it's from an interval of 0 to 2. And then we know the subintervals of the rectangles is 4. So instead, in right Riemann sums, we have to know we take the rightmost value, so we ignore the leftmost value. So last time we included f of 0. In this case, we would ignore f of 0 and include rather f of 2. So let me show this to you guys. And again, we know the delta x, which we had calculated before, but I can calculate it again, is b minus a over n. And in this case would be 2 minus 0 over 4, which is equal to 1/2, or 0.5. I'm going to again use decimals just to make it more clear for you guys. So when we write this down, it'd be r of x. Again, I'm just using r of x, L of x, just because right Riemann sum, left Riemann sum. So, but you guys can, if you go and do whatever, or like, you probably state on if your guys like assignment, quiz, or test, whatever like function to use. So this would be written as 0.5, which we know from the delta x, times f of 0.5 plus f of 1 plus f of 1.5 plus f of 2. Okay, again, it's 2 because you're ignoring the farthest left value in right Riemann sums. And this is basically what the same thing you have to do in, like, if you're given a chart, you'd ignore the, for right Riemann sums, you ignore the leftmost side and then keep the rightmost side. So yeah, just doing these calculations again, it'd be r of x is equal to, again, I did these calculations beforehand, would be 0.5 times times 7.5, and that would give you guys an answer of 3.75 units squared. Okay, moving on to our final example of midpoint sums. So midpoint sums, again, they're like the same concept, but you basically have to use the midpoints. So we're going to use the same problem. So how do we get the x values here? So what I usually like to do is kind of create a chart for the x values. So we already know the n value, the subinterval of 4, and we know it's from 0 to 2. That makes sense to us. And then we know delta x is still 0.5. So we have to now find the midpoint value, midpoints of the equations. So this time we take all the values, 0, 0.5, 1, 1.5, and 2. So what we do in this case though is we group these together. We group these together, these and these values together. That looks kind of confusing right now, but I'll get into it. So I like to do this. First, I like to draw arrow and then 0, 0.5. Then we draw another arrow and then do 0 plus 0.5 divided by 2. The reason we divide it by 2 is because you want to take the average basically of those values. And that will give you guys 0.25 as the midpoint. And I do it again for the second one. You'd keep this value because you used it, because that's like the next inline kind of value. So it'd be 0.5, 1. And then you just simply do 1 plus 0.5 divided by 2, which will give you 0.75. Hopefully by now you guys kind of see the pattern which is going on. So this would be 1, 1.5, and then you do 1 plus 1.5 divided by 2, which is equal to 1. Let me do this calculation, I kind of forgot. 1 plus 1.5 by 2, sorry, yeah, 1.25. And then 4, we use the same process, 1.5, 2, and this would be 1.5 plus 2 divided by 2, which is equal to 1.75. Yeah, okay. Now, again, what you do is just write the equation. So m of x, I'll just write this as, is equal to delta x times f of 0.25. We just use our midpoint values now. Just these values that we calculated for. Plus f of 0.75 plus f of 1.25 plus f of 1.75. Okay. And we know again delta x is equal to 0.5. And then we just multiply that by whatever we get from plugging this into this f of x value right here. And that would be, and adding it all together, and that would give us 5.25. And now we would just multiply all that together, and that'll get us 2.625 units squared. Okay. I hope this video was helpful for finding about Riemann sums, right Riemann sum, left Riemann sum, and midpoint sum. And there's going to be some practice problems for you guys in the comments or the descriptions in one of those below. And hopefully this was helpful. See you in the next video. Thank you.